So the purpose of this video is to show you how to find percentiles using Dr. Stevens' method by finding the percentage of the index number and using that. So this is in WebAssign. One of you asked about the WebAssign version of this question, and I thought I'd just show you this one in the textbook. Now I'm going to only do part A because you already have the answers available to you in the back of the book. See, if you bought the PDF or if you have a paper copy of the textbook, it's back here in the detailed solutions to selected problems. And also in Canvas, I took those pages out and made a separate document, and these are in Canvas course resources. And wanted to point out to those asterisk questions here. My reader's acting wonky, just a minute. Those asterisk questions have all the worked out answers. Usually have all the worked out answers. I was noticing as I was prepping for this video that this one's a little light with how to find, like, find number summary, but he did show you how to do the 90th percentile. Okay, so what does that all mean? Well, the thing you got to pay attention to for this is in the reading in the chapter. So I'm in page 23, and if you go down here where he says talk about the procedure for calculating P sub k, the percentile, the K is whatever percentile you're looking for, and P means percentile. Okay, so they got to put the numbers in order from order. That's the first thing you want to do. And then, fortunately, most of the textbook exercises, he's done that for us. And then it's nice to put an index number next to it. And that's what they did with this exercise set. Let's see, I have it, I clipped it here. See how he added the exercise set? So how do we find these values? Well, if we, let's see what I did. I took this table and I pasted the AM scores. I rotated them, merged all those tables together, and I rotated them sideways so you kind of see visually what's happening. Now I know, so I'm not going to do the percentile method right here for a minute. I'm going to talk about some things. Well, maybe we should do the percentile. The first question was find the 90th percentile, so maybe I should do that first. Let's do this. Let's find the 90th percentile. So I know, come on, there we go. I know that P sub 90 is, we're going to take 90%, right? That's what all it is. The 90th percentile is the number that cuts off the bottom 90% from the top 10%. And to make a percentage into a decimal, we divide by 100, so we get 0.9. And now I see for the AM scores, I've got only 22 people, or 22 scores. So I'm going to do 0.9 times 22. And I don't honestly know what that is. I think it's 18 something, but I'm going to go calculate it to make sure. And so 0.9 times 22, I'm getting 19.8. So if we come back and look at Dr. Stevens' methodology here, if my answer, the index number that gives me the 90th percentile, is not a whole number, then I'm going to round up and use that index number's value to say that's the percentile. So since I've got, where did I do that? Since I've got 19.8, was it? Yeah, where was it? It was right here. 19.8, I'm going to round up to 20, and then I'm going to go to my index number, and whoops, let's go to this. I got this document here. The 20th number, so that means 992 is the 90th percentile of the AM scores. Okay. Now I did a little bit. Do I want to do this? Let me do part. And I don't want to do it. I want to leave it so somebody can post that question. But it'll work. It'll work. The other situation where it says it's a whole number will show up when we try to do the median. So let's come back to my spreadsheet. And now the next part of this question is find the 5-number summary. Well, we know the 5-number summary is, the minimum value, the lower quartile. So 0% of the data is smaller than the minimum. 25% of the data is smaller than the lower quartile. Then we have the median, AKA quarter two, right? 50% of the data is less than the median. Then we have the upper quartile, which we call Q3, and 75% of the data is less than that. And then, of course, we have the maximum value, and 100% of the data is less than that. So in order to find these values, I mean, we can do it with a percent method. Well, I don't think we need to do the percent method to find the minimum, right? I can just look at the data, and I see, oh yeah, 31 is the minimum. I also see that 95 is the maximum. The median is the 50th percentile, right? 50% of the data is less than that. So 0.5 times 22 is 11. Now, here's where it gets a little tricky. I'm going to talk to you why this works. Let's go look at Dr. Stevens' methodology. It says if the index number you want is a whole number, we have to average that value plus the next value to get that percentile. So where did I do that? Is that on the spreadsheet? Yeah. So this tells me, using that method, I have to take the value that's in the 11th index and the value that's the 12th index number and average them. Well, fortunately for this data set, the 11th number is 71. The 12th number is also 71. So if we average those, I hope you see that 71 plus 71 divided by 2 is 71. No big deal here. They aren't always the same. So sometimes you'll get a different value. So the median number doesn't have to be one of the data set numbers. Why does that work? Why do we have to do this averaging thing? Well, if I'm looking for the number that splits this data set in half, I've got 11 numbers smaller than that, 11 numbers bigger than that. So the halfway point is halfway between those two values. Fortunately, as I said, they're both 71. So it's still 71. Now, if you wanted to find the lower quartile, so let me write that down over here, my answers. So that's 71. Now we're going to find the lower quartile, and that's the 25th value. So 0.25 times 22 is, I think it's 5.5. Let me make sure. So I gotta get it back so I can interact with my screen. What did I say? 0.25 times 22. So 5.5. So now in this case, looking at Dr. Stevens' methodology, if it's not a whole number, I'm going to do that rounding up thing. So I was 5.5, so I'm going to go find the sixth value. So the sixth value here is 61. Some people will get confused and they'll write 6 because that's the index number. It's the number you want, the data set number. The index numbers are just a way to keep yourself organized. So Q1 is 61. And then to do the same thing, if we do the upper quartile, so this is Q1, just in case you're taking notes, the median, and this is Q3. Q3 is the 75th percentile times 22. And that's what, 16.5, I think? Let's make sure. I haven't had quite enough coffee yet this morning. So 0.75 times 22 is 16.5. So I have to round up to the 70th number, right? So it's a 70, sorry. What was it? I said, you said, Rainey, he hasn't had enough coffee. 16.5, so I'm gonna round that up to 17. So the 17th value is 87 as I'm seeing it, all right? Isn't that the 17th value? 87. And if you think about it, so let's just step back a little bit. Maybe something you did something like this in high school or middle school. The 61, see, that cuts this bottom half in half because it's a quarter, right? And you see how there's 5 numbers above it and 5 numbers below it. Same thing with this one, 5 below and 5 above. So this percentile method that Dr. Stevens has works. What's nice about it, it works for big data sets. You can always, if I have 500 numbers in a data set, I got to find the 5-number summary. I'll probably use TEC, but besides that, I could use the same technique and find it that way, and that wouldn't be too bad. I mean, if you're doing the crossing out method like you did in elementary school or high school, you know, that would be very tedious with 500 numbers. Okay, so there's my 5-number summary. And then, of course, the last part of this question was to make a box plot. And I know I'm going to do this. People occasionally will do something without a scale. So here, let me write this. I think I can write in this space up here. Be like Taylor Swift and write in the blank space. I know, I'm sorry. My daughter's a Taylor Swift fan. So I need some kind of scale. Now I know I've got 31 to 95. So I'm probably going to start at 30. It doesn't have to be an exact scale, but you do want to make it fairly accurate, because when you're going to start comparing, like for part B of this question, they asked you to do it for the PM scores and then compare them. You want to put those on the same scale. So that way, if you don't use the same scale, then you can't really see the shape and all that. And some people will ignore a scale and they won't even put a scale. Next exam, the first exam, they're going to do this. I ask you to make a box plot, and people will do things like this. And they'll just write the 5-number summary there. When if we graph this, you'll see it'll look a lot different than this. Let's see, I'm going to go to 30. I'm going to go up to 95. So I'm going to go 40. You see, it doesn't have to be a fancy scale. I'm trying to be consistent in my widths, though. And you have to, a graph paper works slick, but you don't have to use graph paper, as I'm trying to show you. 70. I'm just trying to be consistent in my widths. 80. 95. And then you just put a point above as you 31's about here, 61 is about here, 71's about here, 87 is probably about here, and 95 is there. So see, this actual distribution looks a lot different than what that little sketch you made. So what shape is this? I don't know. We're going to get into shapes in chapter 3, so I won't talk too much about that. I don't know. We'll have to, it's kind of weird. The box plot, I'm looking inside the median, it suggests it's right skewed, but then we get this long tail here. So kind of cool. 25% of the data is here, 25% of the data is here, 25% of the data is here, and 25% of the data here. That tells me it's much more tightly spaced. It's clustered together here because that's such a short range. And even this upper tail, that data is clustered together. So, but that's how you use the percentile method. And for any percentile, you can do it. Now make the percentage a decimal, multiply it by how many numbers there are, and then you go find that number based on those rules there about whether or not you get an integer or a whole number. All right, here, let me clear that off. We can get a good clear shot of that. Then use this, and the rounding up versus averaging it too. That's where people get confused. They like the rounding up, they don't like the averaging so much. So if it's a whole number, if when you do this process and you get an integer or a whole number, you need to average the two middle ones, because it's falling in between two of the actual values. Okay, hopefully that helps.